Hi, I'm Honggang. Welcome to Gimba Geek. Around me, there are many entrepreneurs. They are my friends, neighbors, classmates, even family members. Each of them builds something meaningful in their own field. I like to visit them and share the stories with you. When you think of Chinese manufacturing, what comes to your mind? Maybe not just assembly lines or robot arms in car factories. But today, we are going inside something different, a small company in Suzhou that builds custom automation system from scratch. This company is called Boyu Electromechanical Co. I spent a Saturday there, visiting the office, workshop, and meeting the engineers. In this video, you'll see how they design, build, and test machines that don't exist anywhere else. Machines made for one specific customer and one specific purpose. Generally, we'll go through 5 parts: the company story and team structure, the workshop and equipment, how they manage a full customer project lifecycle, the software and AI innovations, and finally, the hardware system and safety designs. Let's start with the story behind Boyu and how a small tooling workshop grew into a full automation company.
My tour began with General Manager Ms. Li, who provided an overview of the company's history and structure. Boyu was established in 2008. Initially, their primary business focused on producing jigs and fixtures and doing precision component processing. The transition into full automation actually stemmed from their original work, as the design required for jigs shares common ground with the design needed for automated equipment. Consequently, the automation department was formally introduced in 2017. Ms. Li emphasized that unlike traditional processing plants, an automation company's core value lies in design. This is reflected in their team structure. They have a complete ecosystem that includes 4 mechanical engineers, 2 electrical engineers, as well as software engineers who write vision software, for example, along with fitters and wiring and commissioning staff. A defining feature of this industry is that engineers are constantly on the move. When projects are busy, staff are typically deployed to client sites for commissioning and on-site service. It is only during slow periods or between projects that they return to the office.
What really impressed me is how complete the engineering ecosystem is, from mechanical and electrical design to on-site debugging. It's a small company, but it functions like a full R&D lab. Next, we are heading to a workshop, where the real machines come to life.
Next, Ma Gong led me through the assembly workshop. This area is distinctly different from a typical machining or stamping facility, as its primary function is the assembly and final performance debugging of equipment. We saw several pieces of equipment currently in the assembly process, including sophisticated inspection machines. First one was cutting blade inspection equipment. This machine is used to inspect extremely thin cutting blades, which the customer considers a consumable wear part, but for Boyu, it is a product being inspected. The machine performs dimensional measurement and appearance inspection. The inspection is entirely non-contact, utilizing cameras, specifically KS cameras. The workflow involves several automated steps. Operators manually place the blades into a cassette. A servo system pushes the blade into position. A camera performs appearance checks and measures length dimensions. A robot uses a suction cup to pick up the blade for measurement of width and bevel angle, utilizing a profile inspection system to check thickness and angle. Finally, the machine sorts the finished blades into OK and NG bins. The NG products are segregated so the client can perform a secondary confirmation before determining if they can be used. The second one was an automatic in-process measuring equipment. We saw another machine resembling a projector with a lens located underneath. This machine is specialized for checking the product's cross-section. Ma Gong explained that this type of equipment is typically embedded directly within the production line to perform in-process inspection. The third one was a centrifugal barrel finishing machine. Ma Gong also pointed out several identical machines called centrifugal barrel finishing machines. These machines are used to process products that have angular or sharp edges, such as small particles formed after cutting and sintering. The product, along with an abrasive medium, is placed inside canisters. The machine operates similarly to a washing machine, performing a centrifugal rolling process. to deeper or round the edges of the product, thereby improving its appearance and performance. This is an essential downstream process step for the client. I also observed an electrical engineer performing final performance debugging and confirmation before shipment. Ma Gong clarified that for simple movements, this debugging can be done entirely in the factory. However, for devices involving complex motions, the electrical engineers must go on-site to assess and optimize the program.
Each of these machines is custom built. There is no blueprint, no standard model. Everything starts from the customer's idea. And that's what makes this industry so fantastic. In the next part, we move to the meeting room to understand how Boyu turns a single request into a complete project.
We continued the conversation in a meeting room. Ma Gong detailed the crucial stages of handling a non-standard automation project, emphasizing the customer life cycle. First step was requirement gathering and feasibility evaluation. The client presents a need perhaps to apply tape or labels to a product and provide samples or dimensional data. Boyu's team internally discusses feasibility, costing, and evaluates important parameters like cycle time and delivery schedule. The second step was solution development and negotiation. They present a preliminary plan and a quotation. If the client shows interest, there are typically multiple rounds of communication, sometimes long and drawn out. Since the client is more familiar with their specific on-site process, Boyu refines the plan based on customer feedback. Thirdly, it was final design and production. Once the plan and quote are finalized, detailed drawings and the bill of materials are generated. Simultaneously, purchasing begins, and electrical engineers start programming the PLC logic. This programming, including the PLC logic, is designed in-house. Fourth step was assembly and optimization. After mechanical assembly and electrical wiring are complete, the team continuously refines the program. They focus not only on accurate operation, but also heavily on safety measures and mistake proofing. The fifth step was client acceptance and delivery. The client provides a small batch of their actual product to Boyu's facility for dry runs and small-scale testing. Once approved, the equipment is shipped. Next step was on-site commissioning. Boyu staff are sent to the customer's site to accompany the run for a period, often about a week, during the initial mass production phase. This allows them to make final adjustments for real-world issues. The ultimate goal of this residency is to train the client's internal equipment maintenance department so that Boyu's engineers can withdraw promptly and start the next project. Ma Gong noted that winning and retaining clients often begins with simple projects to build a relationship of trust. Long-term cooperation is highly valued in the custom automation field because sustained after-sales service is vital for non-standard equipment whose future performance is unpredictable. As Boyu becomes familiar with the client's products and production processes, collaboration becomes easier, which is crucial for efficient future equipment development.
Listening to Ma Gong made me realize how process-driven automation really is. It's not just about making machines move, it's about managing communication, iteration, and trust. Next, we'll look at the software side, where Boyu integrates AI and vision systems into the machines.
Electrical engineer Xu Gong elaborated on Boyu's rapid adoption of advanced vision and software technologies. He emphasized that the company consistently strives to be at the forefront of the industry, moving from purely structural equipment to integrating software platforms. First case was transition to vision guidance and quality control. Boyu started with CCD visual positioning for basic handling tasks, such as assisting robots in picking up non-standard products that include cables, a process that compensates for the limitations of relying solely on high-precision fixtures. However, market competition drove clients to demand more, integrating quality detection and defect recognition into the material handling process itself. Xu Gong provided two strong examples. First one was traditional industry challenge. Even highly traditional products like heat sinks now require inspection machines. This is because their downstream customers are increasingly relying on automation, which mandates extremely strict dimensional and appearance standards. If the heat sink dimensions are slightly off, the client's robotic assembly system cannot compensate. Second case was medical industry, TCM. Boyu developed inspection systems for Chinese medicine needles, including detecting bent or damaged needle tips. They also perform checks on the final packaged product to ensure the correct count of needles per pack and proper sealing margins. This system replaced manual magnifying glass-based spot checks with high-speed, 100% full inspection, requiring the cameras to take and process over a dozen photos per second. Here is another case integrating AI algorithms for products that are completely irregular, oddly shaped, or even move during inspection, like certain agricultural seedlings. Traditional industrial camera algorithms are inadequate. Boyu responded by developing its own proprietary AI algorithms, utilizing deep learning to identify and capture shape features. This dramatically expands the coverage area for detection compared to traditional methods. Training the AI requires large amounts of data from both good and bad products. The intelligence is developed on training machines within Boyu, and then the final inference machine is deployed at the customer's site. Other software applications include appearance inspection of automotive interiors, monitoring the torque feedback during screw fastening, which integrates with the client's factory system to share real-time data, and performing final packaging checks like presence and absence detection, barcode scanning, and missing component detection. Xugong summarized Boyu's software architecture offers strong universality, although application requirements differ drastically across sectors like consumer electronics, medical, or auto. The underlying software typically only requires algorithmic adjustments.
I didn't expect to see so much software innovation in a factory this size. They are not just building machines, they are building digital intelligence that runs those machines. And behind that software, there is also precision hardware, which brings us to the final part of this story.
Mechanical engineer Shigong provided a detailed walkthrough of the physical system used in an automatic pressing device for electric vehicle parts. Part 1 was the hardware process. This device handles multiple assembly tasks, including installing steel thread inserts and pressing in locating pins and water nozzle. Thread insert installation. The main part is manually loaded, but the steel inserts are fed automatically. After the insert is screwed in, an air cylinder performs an extra step to punch off the insert's tail, followed by a camera inspection to ensure the tail has been removed, pressing and gluing. Before the water nozzle is pressed in, specialized tooling is employed to apply glue automatically. Customer specifications require glue on both the inner hull of the aluminum parts and the surface of the water nozzle. This is achieved using a rotating glue dispensing fixture driven by a servo motor motion control. The device uses an XYZ mechanism to achieve movement across the plane. The second part was precision and calculation. Precision is paramount during the final assembly steps. When pressing in locating pins, an interference fit, or hard insert, the system must accurately monitor displacement and force or torque. This relies on both the servo motor controls and the pressure sensors. Mechanical design acts as the skeleton of the equipment. Designing the structure requires theoretical calculation based on customer specifications, such as required pressing force and depth. For instance, if the calculated force is 1,000 kilograms, they might select a press rated for 2,000 kilograms for redundancy. The third part was modularity and safety features. Shigong confirmed that Boyu leverages accumulated project experience to establish internal standard assembly modules and components. When approaching a new project, they can pull these modules and adjust dimensions, greatly speeding up the process and forming a valuable technical moat. Safety is a strict, mandatory requirement. The machine frame is fully enclosed, and open access points are guarded by safety-like curtains and security locks. If a door is opened, the entire system immediately ceases operation, ensuring worker safety. Furthermore, the design incorporates ergonomic features, such as adjustable, retractable casters at the base, allowing workers to easily move the heavy machine short distances within the workshop without hydraulic trucks.
Standing next to these machines, you really see how much mechanical engineering and software are merging. Every servo, every sensor, every safety curtain is part of one living system. This visit to Boyu gave me a new perspective on China's automation industry. These small, engineering-driven companies may not be famous brands, but they are quite building the backbone of modern manufacturing. Thanks for watching. See you next time.